Hey, what's up, Ziguanas? Long time no see. This is day 26 of the 30 Days of Z Coding Challenge. Join me as I apply over 2 decades of professional programming experience and around 15 years of teaching experience to master a new language. Zig, my name is Dusan. Welcome to Zignited. So today on the menu are tests, Zig tests. Let's jump right into it. Code written within one or more test declarations can be used to ensure behavior meets expectations. Okay, let's see. Okay, they say expected one adds 1 to 41. The standard library contains useful functions to help create tests. So you don't even have to import. It's within here. Then what they say, expect is a function that verifies its argument is true. This one. It will return an error if its argument is false to indicate a failure. Try is used to return an error to the test runner to notify it that the test failed. Okay. So it will return, expect verifies if it's true. True, it will return an error if its argument is false to indicate a failure. Try is used to return an error to the test runner to notify. Okay. So here they call this add1 function, which is here. They pass 41 and then they expect the result to be 42. Here, let's see what they do. Add1 has one parameter of type i32, returns the same type, returns number plus 1. Okay, pretty straightforward. And then they have another test here, which is literally the same. A test name can also be written using an identifier. Aha, okay, so I missed this. So they have the name for it. This is a doc test and serves as documentation for add1. Okay, let's see what they have here. Test okay, test introduction Zig. Testing introduction test expect add1 to 41 okay. The second one. ECL test add1 okay. So for this one, it doesn't say text expect done. Test expect add1. It says declarative test, or how they call this one, dot add1. Okay, and then both of them pass. Okay. Then the next thing, testing introduction Z code sample tests the function add1 to ensure that it returns 42 given the input 41. From this test perspective, the add1 function is set to be code under test. Zigtest is a tool that creates and runs a test build. By default, it builds and runs an executable program using the default test runner provided by the Zig standard library as its main entry point. During the build, test declarations found while resolving the given source, Zig source file, are included for the default test runner to run and report on. Okay, then they have this note. This documentation discusses features of the default test runner as provided by Zig standard library. Its source code is located here. Okay. Then let's see the shell output shown above. Displays 2 lines after the Zig test command. So they speak about these. These lines are printed to standard error by the default test runner. 1 of 2 testing expected one adds to 1 to 41. Okay. Lines like this indicate which test out of the total number of tests is being run. In this case, 1 of 2 indicates that the first test out of total 2 tests is being run. Note that when the test runner program standard error is output to the terminal, these lines are cleared when a test succeeds. Okay, so they have just like temporary. Testing, so 2 of 2, testing introduction. Okay, when test name is identifier, the default test runner uses the text decal test instead of test. This line indicates the total number of tests that have passed. So this one here. Test declarations contain the keyword test followed by an optional name written as a string literal, or an identifier followed by a block containing an invalid Z code that is allowed in a function. So string literal or an identifier. Okay. Non-named test blocks always run during test builds and are exempt from skip tests. Test declarations are similar to functions. They have a return type and a block of code. Yeah, so that's what we've seen here. Okay. The implicit return type of test is the error union type, any error union void, and it cannot be changed. When a Zig source file is not built using the Zig test tool, the test declarations are omitted from the build. Okay. The declarations can be written in the same file where code under test is written, or in a separate Zig source file. Since test declarations are top-level declarations, they are order independent and can be written before or after the code under test. Okay. Then we have Doctests. The declarations named using an identifier are Doctests. The identifier must refer to another declaration in the scope. A doctest, like a doc comment, serves as documentation for the associated declaration and will appear in the generated documentation for the declaration. Okay, an effective doc test should be self-contained and focused on the declaration being tested, answering questions a new user might have about its interface or intended usage, while avoiding unnecessary or confusing details. A doc test is not a substitute for a doc comment, but rather a supplement and companion, providing a testable code-driven example verified by Zig test. Test failure. The default test runner checks for an error returned from a test. When a test returns an error, the test is considered a failure and its error return trace is output to standard error. Total number of failures will be reported after all tests have run. Okay. So they don't stop. That's important to say that they don't stop. If there is an error, they will just keep running tests and then summarize. Okay, it's testing failure. Expect this to fail. So as the testing expect false. So then this is hard coded to fail. And then this one to succeed a similar way. Then we have standard running the first of two, the second of two. Then fail, test unexpected result. If union okay, return error. If not okay, sorry. If not okay, this is a negation, okay? Test unexpected, okay. So in this case, it failed, of course, because they hardcoded false. Then the second one is just passing, saying okay. And then finally they have the summary, which is pretty standard in any other language. So one passed, 0 skipped, 1 failed. And then the error, the following test command failed with exit code 1. Okay. Skip tests. One way to skip tests is to filter them out by using the Zig test command line parameter, which I will have access to soon, as soon as I install Zig. Minus test minus filter, and then text. This makes the test build only include tests whose name contains the supplied filter test. Note that non-named tests are run even when using the filter command line parameter. Okay, though to programmatically skip a test, make a test return the error. This one, skip Zig test, and the default test runner will consider the test as being skipped. The total number of skip tests will be reported after all tests have run. Okay, this is the example test, and then they just return skip Zig test error. One testing, 1 of 1, 0 passed, 1 skipped, 0 failed. And here it was 1 passed, 0 skipped, 1 failed. Okay. Report memory leaks. When code allocates memory using the Zig standard library, some libraries testing allocator, standard testing allocator, the default test runner will report any leaks that are found from using the testing allocator. Let's run this just for fun because I haven't run any of these. And this is the code from today, which I can delete now. Let's say record root source file struct play has no member main. Ah, okay, because I deleted the main function. So let's do undo and let's leave the main. So here. Okay, and let's see what they expected to see. Detect leak. So the import standard, okay, detect leak is the name. Then var list, std array list u21 dot init. So they initialize the array list with this allocator. Then it's missing the defer, which leaks the memory, right? And then they try list append, and they try to append this umbrella emoji, and then they run this test here and expect the list items length to be 1. Testing, okay, detect leak Zig 111, testing detect leak, test detect leak, okay, memory address leaked, okay, all 1 test passed, 1 errors were logged, 1 test leaked memory. Okay, let me see why I don't see here anything when I run. Let's try to run another test. This is pretty straightforward, not playing with memory. Yeah, and what if I just put it inside of the main? Okay, so this is something because I'm running it online, I believe, because I'm not running it locally, so there is something different. Hilux looks welcome. So this is, I'm playing with Zig, so I'm reading the docs about testing Zig. So if you're not familiar with the channel, I'm learning Zig for 26 days in a row. So I started with 0 Zig experience, but I do have a lot of experience with other languages. So I'm just documenting the process of learning Zig from scratch. Okay, so memory leaks. Then the next thing, detecting test build. Use the compile variable is test to detect a test build. Aha. Okay. Okay, so they take the built-in from here. Then they have is a test function. Return built-in is a test. So let's try to do this. Built-in expected effects. Okay, Let's see now. Again, yeah, so this is definitely the environment. I will not test, I will just read what they say. So first they take the std library package, then from the testing expect they take that structure, whatever it is, and then compile variable okay is test. So they assign it here to the constant, then they have this function is a test which returns boolean true or false, and then return built-in is test. So they will try to see if this is a test or not, and in this case it passes as a test, so it is by default a test when you do this. Okay, look like JavaScript. Yeah, so all the languages are more or less similar if you just like briefly look at them, but the way they work is completely different. So the main difference between JavaScript and Zig is JavaScript is not compiled language, it's interpreted, so you just write it and run it. And Zig is compiled to zeros and ones, and then you run it in that way. So one of the differences, but it's also very different because it's a low-level language. So you directly play with memory, and in JavaScript you don't have direct access to memory, and so on. So you can take a look if you want some of previous videos that I made here, previous streams. I went through literally the entire documentation, so I'm literally finishing now documentation. I'll have maybe tomorrow and maybe one more day to go through it, and that's about it. And I also did some coding, so you will have, I think, 4 or 5 videos that are me coding live and playing with these things that I learned from Zig, about Zig. Okay, so this one is next, test output and login. The default test runner and Zig standard library. A Zig standard library is testing namespace, output messages to standard error. Okay, that's already said before. The testing namespace, Zig standard library's testing namespace contains useful functions to help you create tests. Okay, in addition to the expect function, this document uses a couple of more functions as exemplified here. Let's see what they do. They create one constant. They call it expected. I32 is the type, and they set it to 42. Then they create another constant. They call it actual, and they set it to 42. Then what they say in comments, the first argument to expect equal is the known expected result. The second argument is the result of some expression. The actuals type is casted to the type of expected. Then they have this try testing expect equal, and they try to compare them. So here the actual, like they say, is the argument is the result of some expression. So in this case, they treat this as an expression. So it's a simplest expression possible. Then they have another test, expected error, actual error union. So they take the demo error from this error built in, and then they have the actual error union, where they actually create a union of any error and void type. They create a union, and then they assign the demo error to it. So they are assigning it to this part of the union, let's say. Then expected error will fail when the actual error is different than the expected error. Okay, so they try to see what is the expected, and if it's the same, like this one here, and in this case it's the same, so that's why of course it passes. So both tests pass. Okay, the Zig standard library also contains functions to compare slices, strings, and more. See the rest of the standard testing namespace in the Zig standard library for more available functions. Okay. So You can also compare slices, strings, and more and more. Test tool documentation. Zigtest has a few command line parameters which affect the compilation. See test help for a full list. Okay. And then we arrive to variables. I've done them before, so I will not do them again. I'll just go to the opaque. And let's see. So it's a very small thing. So this one will be a short stream, I believe, because all the other things that I can do are, I believe, much longer. Actually, let's see. Let's do the opaque first. Declares a new type with an unknown but non-zero size and alignment. Yeah, I kind of went through this once. I remember this. It cannot contain. It can contain declarations the same as structs, unions, and enums. Okay, they create these two constants. They are both opaque, and then they have this external function called bar. Then they take in one parameter, which is a pointer to derp. So this one here, and it returns nothing. And then they have another function called foo, which takes one parameter called w, which is of type pointer to what. And this one returns calc conv. I'm not familiar with this. Call, not calc, sorry. Call conventional. So this is interacting with C language, calling something down the foot. So they will probably explain here. Maybe they will not. And then the void is the. So this is also confusing how they have these two things together. Void call to the conventional C or something like that. I don't know how they officially call this one. And then they call the bar function from here with which returns void. Okay. Then they test foo for the undefined. So this one. And let's see what happens. The expected type is the pointer to the test opaque derp. Found test opaque what? So in 6, where is this? 1, 2, 3, 4, 5, 6 here. Okay. Yeah, they say here. Okay, so they say where? So here, they expect to see the pointer to test opaque derp, so which makes sense. This is what they say here, but they are sending a wrong one because here they receive the pointer to what, and then they just pass it in here, and that's wrong. Then let's see the other part. Not pointer type child. Test opaque what cannot cast into pointer type child. Test opaque derp. Okay, this is now the second stage of the error, right? So they say that this is also the reason is because it cannot be cast automatically. Then, hello Andre, welcome back. Call conv applies to function, not return type. Okay, thanks for clearing it up. Okay. So it's in somehow modifying or doing something with this function, right? Let's see what's the next thing. Declare here. Okay, derp opaque. So here they are now going one step deeper. And then here in the next one, they say parameter type declare here. So yeah, so they're just like linking all the things together, putting them all together. Okay. So this is a bit confusing, but I understood the main context that's important. Now let me see, because I finished with opaque. Let's see what Andre says. Basically, in assembly, there is no such thing as a function to call, a so-called convention. A convention on how to convert function into assembly. Yeah. So in assembly, you have just like opcodes, and you push data into accumulators, and the data and opcodes and you jump, and yeah, no functions. They have macros, but this is, you just jump to a part of the code and then you jump back. Or all convention is a convention. Thanks for explaining. Okay. Code with Ganjan, welcome. Hello, sir. I'm from India. Hello. Greetings to India from Europe. And welcome. So I went through opaque, and most of the things I've already done. So let me just double check if there is something remaining. But I believe there are just a few things remaining that I can potentially do. So build mode, I will have to do when I install. Again, single threaded builds, the same. This I did, did. Big build system did. So C, WebAssembly. That's literally only thing that remains. Target style guide, we went through it. Source encoding keyword, literally everything. So WebAssembly or C. Let me just see how long are they. So if it's a huge topic or not. It's not that. So WebAssembly is a short one. Let's see the C. So maybe I can do WebAssembly now, just to finish that one as well. And let's see the C. So C looks like it's a bit bigger. So then definitely I will not do C integration today. That will be then for tomorrow, day 27. And then literally after this C, I will not, I have to do, and on Saturday I will have to install Zig. So my plan to go until day 30 without installing Zig are falling apart, my plans. Okay, let's see the WebAssembly. This is one of my favorite things. I haven't done it in Zig, obviously, but I did play before with Rust some 6 years ago. Okay, so WebAssembly. Zig supports building for WebAssembly out of the box. That's cool. Freestanding for host environments like the web browser and Node.js, build as an executable using the freestanding OS target. Here's an example of running Zig code compiled to WebAssembly with Node.js. So of course I will play with this once I finish all these 30 days of coding challenge and go through the basics to just like see what is there and how to have the idea how it works. Then I will practice, and I will do this as one of the projects because I love WebAssembly. So let's see what they do. Here's an example of running the code compiled to WebAssembly with Node.js. So extern function print i32 void. So this is the signature, right, of the function. And then they have export function add, which takes two parameters, a and b, both of type i32, and it returns void, and it just prints a plus b. So two functions, both void, return. One takes only one i32, and this takes two parameters of i32 type. And then in the shell, build exe metzig. So metzig is the name of this. Target WASM 32, freestanding. Fn no entry, function no entry. This is, I guess, because you don't have the main. You don't have the main function, so you're just building this as, let's say, a library. Let's say like that for JavaScript to interact with. Okay, and then export equals add. So it exports only this one. Okay, let's see what happens here. Test.js, okay. So they create one constant. So this is now JavaScript, not Zig anymore. So this is like import. They import the fs, which then they use here to read. So this is just like the Node.js thing, because in browser, if you actually use WebAssembly, because it's sandboxed in the browser, you would not be able to read anything from file system. So this is just the example where they use WebAssembly outside of the browser. And in that case, you have access, of course, to operating system and to file system. And then what they do is they use the FS module, which is a built-in in Node.js. Well, it comes pre-installed, right? Then read file sync. This is synchronously reading the file, because you can also have asynchronous reading. In this case, they would basically, this means it's going to wait until the finish, until the file finishes loading. So it will pause here, the code will stop here, and it will wait for the file to be loaded before it moves on to the next line. And it will store the content here in the source. Then they create another constant, so a JavaScript constant, not a Z constant, of course. They call it typed array, and then instantiate here the uint8 array of the source. Okay. So this is, if I remember correctly, I haven't touched WebAssembly for literally, when I played with it 6 years ago, I needed it for my, how it's called, bachelor work. So I did part of it in WebAssembly and Rust. And yes, I went to university very late. So I started with 33. Then I basically passed all the exams by 36. But then I literally, I had only to graduate, and I didn't for years. I was working, and finally I decided to graduate in 2019. And that's when I had to write the bachelor work. And that's when I played with WebAssembly and Rust. That was only a part. So I didn't have any subject on my university about Rust or WebAssembly. So it was very new. WebAssembly was in 2017. They started to support it in browsers. And I was doing this in 2019. So it was very, very early. And I just found a way to make it a part of my bachelor work, because I wanted to do it. It was very interesting. And I remember that in a nutshell, WebAssembly shares a part of its memory, and you can set these things up when you make a module, a WebAssembly module. It shares its own linear memory with JavaScript, and that's how you can exchange the information. So you have to go to this shared part of the memory, and then you don't have access to DOM in browsers. You don't have any things like that, but you can provide some data for the JavaScript to use to update something. For example, what I did in my bachelor's work, this was just like a very simple thing to do, nothing too hard, just to demonstrate the point. So I used JavaScript to animate the SVGs that were integrated into the page. So for example, it was some triangle, let's say, was one of the shapes integrated in the HTML. And then JavaScript would change the coordinates of the triangle, so the coordinates of the points of triangle. But the JavaScript did not calculate what will be the next point. That was done by Rust, compiled to WebAssembly. So Rust had the logic. So I created some simple animation. So I just moved linearly. I changed the y coordinates of one point of triangle in Rust, and it was cycling like this. So it was, I forgot what was the frame rate, doesn't matter. And then it was updating this linear memory regularly, and then JavaScript would just like reading what is the position of this y coordinate for this triangle, and it was just like getting it and then updating the triangle, because you don't have access, you don't have DOM access, you cannot do anything outside. You're sandboxed in the browser with WebAssembly. But this is different. They are using it with the Node, so not on front end, not in browser. So that's why you have the access to files. Let me see what you guys wrote. Sorry for speaking a lot. Hi, Robert. What Andrei says, call conv, C is calling convention from C language. In C, all functions called in the same way, but in most languages, such guarantees are absent, including Zig and Rust. Thanks for clearing this up. Then Code with Ganjan says, actually, sir, I need a job, but I have no job. I am a front-end developer and I am a fresher. I know HTML, CSS, and JavaScript. Please, sir, I need job. Please, sir. Yeah, I would love to offer you one, but I don't have any company. I don't own any company. I'm freelancing myself, so I'm working for clients when they need something, when they need. So I have some regulars, but that's pretty much it. Okay, let's see the next thing. Next line. So this is how they instantiate the uint8 array, which is basically going to be this shared memory, if I'm remembering correctly, or which JavaScript will have access to, and also in this case Zig from inside. WebAssembly dot instantiate, and then they have this typed array. They pass the array as the first parameter in JavaScript. Then the second one, I have to be careful here because it's not so easy to see where it ends. So here it's the first curly brace, the second, the third, then the third ends, then the second and the first. So here is here it stops. So this is the second parameter, and this is okay. This looks like a promise, right? So because it has then at the end, so this is asynchronous now code, so it will do something here. So I will see in a second what exactly, and then it will, after it's done, it will then oh, this is error function here, this is error function, so anonymous function in JavaScript. So after it does the first thing, which I will come back to in a second, then it will take this anonymous error function here, and I have to be careful again for the curly braces here. So it will run this one. It's like a one-time function without a name. And then they create a constant add, and they take the result instance. So this is, if there is no error, this will happen. So result will exist here. And then they take the instance from the result, exports add, which basically is their way of accessing this shared memory with WebAssembly. So this is JavaScript, but it reaches into WebAssembly, the shared memory with WebAssembly. It takes this piece of code where actually the Zig compiled the binary for the function add, and it then assigns that as a reference to this add constant, and then they call. So this is now just a JavaScript name, JavaScript constant, and they use it as a function. They just call it, and they provide these two elements, two numbers, and this is, of course, in this case, it's a JavaScript type, so it's called number in JavaScript. They, under the hood, it's a different thing what happens, but JavaScript doesn't have separate numerical types. It's just called the number. Or floats and integers, they're the same type. And this is what they then add, and then, of course, what you have running in the background, the support, the browser knows how to take this JavaScript input, convert it to a specific zeros and ones sequence, and then inject it to this WebAssembly shared memory, so that it will trigger the function that is there fixed in that part. And let me just see now, the only thing that is missing is the first part of it. So let's see what they do. They have, again, one anonymous function for the result. They take the result, then they console log the result is, and then they just, so this is like string interpolation in Java. So if you have these ticks, you can do that. So like in Rust, but in Rust you just don't have the dollar, sorry, in Zig, I was speaking of Zig. So in Zig you don't have the dollar sign. You would just have here comma dot curly braces, and then inject this there. So this is the same thing. So they're just, console log is like a print, so they will just print what is the result. Okay, and they also create, so this is an object that they have. So this is like a struct in Zig, right? It's an object. And this is the first field of an object. And what they will do here, they will take this anonymous function. They will input it. So this will basically be the name for that function. You can think of it like that. So it's like you're having the print as a function, and it is going to take this result and print. Okay. So then you have the output here, and they run this test.js, and they say the result is, and then 3. Okay. And let's go back because I already forgot what was the Z code. Yeah, this is because Zig internally calls, so they add internally calls print. I was wondering like about this, but this is internally. Okay. Now it makes sense. And let's see what you said. Andre says Zig standard library docs, one where you read std debug full panning. Yeah, I remember this one that you suggested. That I take a look when I was dealing with this panic part. Implemented in JS plus Z compiled to WASM. Oh, nice. Nice. Hi, Jorge. Welcome. Haven't looked at WASM in Zig, but the console log looks like JS syntax. This is JavaScript. So this is this doesn't have to do anything with WebAssembly. So WebAssembly part is coming from here. So what you do, you write Zig code, or in this case, it can be Rust, it can be whatever you can compile to WebAssembly, whichever language supports the WebAssembly as a target. So you literally write a Zig code. Then when you compile, you have here what they do. So they say the target of compilation is WebAssembly. So it's literally compiling to zeros and ones for this imaginary architecture that doesn't exist. So normally you compile to a specific processor that exists. So for example, I don't know, M3 for Mac or M4, doesn't matter. So you would target a specific processor, and then you will have this specific sequence of zeros and ones that match the machine code and data for that specific processor. And in this case, they are compiling this into WebAssembly in this WASM 32. So this is the architecture is 32 bits. So it's an imaginary processor that doesn't exist, but it virtually exists in all of the major browsers today. So Chrome, Mozilla, Edge, and Safari, they all support. They're not the only one. I'm just like mentioning the major 4 ones that for sure support WebAssembly from 2017. And then when you do this, so you have literally like the machine code running in your browser. So before 2017, the only engine that existed in browsers, in at least the most popular and widely used browsers, was JavaScript. So you could run only JavaScript. You cannot run Python, you cannot run C or anything other than JavaScript in the browser. They didn't understand in 2017. But then they added this support for WebAssembly. So now every browser that I mentioned at least understands machine language of the WebAssembly imaginary processor. So it's literally like you have a virtual processor running in your browser as a runtime. So this is what you do. You compile Zig into zeros and ones for this architecture, in this case in WASM. And this is a JavaScript code. And I was mentioning before, probably wasn't here. So I was mentioning that these two engines that you have now in browsers, they can communicate because there is a piece of shared memory. So you can expose, you can all set these things up. So this is all subjectable to customization. So they share the memory. So of course you have stack and heap, and like you have ROM in some instances. So it's the same with WebAssembly. So you will have this unchangeable, fixed, immutable part of the memory where you will have the binaries of the functions that you define. So in this case, these two. So print and so this is I believe this is just like exposing the print of the native one from Zig. I'm not sure like what they do here. Like the Zig part is the part that I'm not sure. But let's say that this is just like two functions that they're custom. That this is not a built-in one. So they are just like making a binary of this function and having that in the piece of the memory, which you cannot change. So it's not like changeable. You cannot delete this by accident. So that's set up in that way. And then what they do here, this is JavaScript. So this is now running in this JavaScript engine in the browser. And it has the support under the hood. The browser knows how to provide input and output to JavaScript. In the similar way, I don't know how much you're familiar with JavaScript, but in a similar way, how you can how JavaScript can access DOM. So DOM is not something built in JavaScript script. It's actually memory that is managed by the browser itself. But there is this API that browser opens to JavaScript. So so JavaScript can say, hey, tell me what is in this HTML page, because it's already parsed. Browser already parsed that, and it keeps it in its own memory. And then JavaScript says, hey, give me, like, I don't know, this H1 header from this page. So it goes through browser, and this is just like one example. You have different APIs, of course, not only for this. And in a similar way, you have the browser support that communicates between, so browser communicates with JavaScript, and it also communicates with the WebAssembly, and that's how you can interact. So in this case, what they do, they load the WASM module here from the file, then they create, this is just like a JavaScript array here. Then what they do here is they have this WebAssembly, which is, you can think of it like an API for JavaScript. So this is a browser giving a JavaScript control of specific things. And then JavaScript says here, hey, I want you to access this memory that I share with WebAssembly, and get me this add function from, and of course you have to have the ABI, so there is things under the hood that happen. But in this case, it knows, the browser knows where this is, and it will just take that shared piece of the memory and provide it to JavaScript. So you're then saving that reference to that piece of the memory where there is a binary compiled Zig function. And at this level, it's not Zig anymore. So when you compile it, it's just like a bunch of zeros and ones. So it runs the machine language of the processor. It's not Zig anymore. But it was made in Zig, right? So then you have this address of this function in binary, and then you have you assign it here to the constant, the JavaScript, and then you call it as a normal JavaScript. This is kind of like it's creating a wrapper, a JavaScript code that under the hood browser will redirect to this specific point of memory, and it will treat these zeros and ones as something that JavaScript can understand, and it can pass. You see, it can even exchange the data. So this is, of course, you have to define here how they communicate, like an interface. And so this is literally like an interface here. So JavaScript will be able to do whatever you say. And of course, the types are different. So in Zig, you have I32. In JavaScript, you don't have I32. So you have number is the type. You have numbers that are floats and integers that are all grouped together as one type. Then, of course, it can be tricky depending how you write the code and what you want to do with JavaScript. If you wanted, for example, here to pass something that is larger than this type that internally this assembly code can accept, then you'll have problem, of course. But if you do everything that is logical to do, then you can use these functions in this way. And not only functions, they also share the memory. So I gave the example that something that I did for my bachelor. So you don't have only this, like, let's say, read-only part of the memory, but you have also the working memory where you can share the data. So your Zig compiled code can calculate something that is, let's say, some code that is very, very sensitive to processing time. So let's say that you have to crunch a bunch of data. So something that JavaScript will handle for a long time, and it will just like lose the, for example, if you have live video feed and you want to add some effects. So let's say I'm now streaming this, and then I want to have my effect that something's happened when I move the hand, that there is a delay, that you see my hand like this, and I change the colors and I apply some bunch of video effects, and I want to do these effects in the browser. So there is no way JavaScript can handle all this. If I exaggerate with the effects, then you will see instead of, I don't know, 60 frames per second, it will start to slow down, and you will see like 2 frames per second like this, and it will be very unwatchable. And then you can actually do that in Zig, for example, compile it to WebAssembly, and then process the data. But of course, JavaScript will read 60 times per second because it's fast enough to do that. So it can read your result 60 times per second and just like displays this as a bunch of pixels on the screen. So this is kind of like the idea of WebAssembly, that it's complementary to JavaScript, and you run it in such way that you combine both of the best of the two worlds. And you cannot, for example, from WebAssembly, you cannot directly access, like you cannot ask what is the title of the page. So it's sandbox completely. You can just share this piece of the memory. Of course, you can make a code that will then, a JavaScript will see what is the title, and then it will provide information to WebAssembly, and then WebAssembly can do something with it. So that's of course possible, but it's kind of like going around and it's slowing things down. They are working on it, so I haven't followed what they are doing in the last few years. It was all like 5 years ago. They said, "Oh yeah, we're working on it." So we are working on access to DOM, but as far as I know, last time I checked, it doesn't work yet in WebAssembly. And this is not related to Zig. So this is like WebAssembly is just like compilation target. So you can compile C, Zig, even Go. There is this tiny Go compiler. I don't know how it works, but it doesn't include garbage collector somehow. I don't know how. So TinyGo is some implementation of Go without a garbage collection. I have an idea how. I've never used. I used Go, but the normal, the classical one. I never tried to use this TinyGo. Yeah, so this is in a nutshell. Let me see. Sorry, guys, I speak too much. Maybe. Let's see what you wrote. Then Jorge says next that it says, yeah, Jace, yeah. Andre says then, yeah, it's sometimes I don't see also like the thing that is written like. So one of the examples, this part here, I didn't see that there is format and light here, that you can change the light and dark mode before someone of you guys mentioned. So I just like saw run. And then I was wondering, and I was like complaining how it's hard to compile, how it's hard to format here because it's not IDE. And then someone said like, you literally have format here. Yeah, happens. Andre says, sadly, compiler itself can't be compiled to WASM yet. The compiler itself. Okay. So Zig Playground you're using runs compilation on a server. So it sends it to a server, compiles it, and then it responds as some kind of whatever, like JavaScript or maybe pure HTML. Jorge, thanks for the explanation. I didn't know JS and the WASM sandbox shared the memory like that. Yeah, it's customizable, so you can. So there are of course some restrictions. I really forgot because I haven't touched this for 6 years, and I only did it once, like for my bachelor work when I need it, and I forgot, of course, when you don't use. But it was something like you can say, okay, this much memory I will share because I need to, and of course you have some limitations, and maybe they even change something in 6 years, very probably. But in a nutshell, this is how it works. So you have part of the memory that you share, but you cannot change. And you have the part of the memory which you can say, okay, this is the part of memory which I will share. It's writable from both sides. So JavaScript can write into it, and WebAssembly can write into it, and read, of course. Jorge says the normal Go compiler does target WASM. Yeah, so they probably made some changes in the last 6 years. So what I'm saying was actually what happened 6 years ago when I was learning WebAssembly. Those days they were saying like Go. I think actually, if I remember correctly, so maybe I'm wrong, but I think that they also compiled even then that they used classical Go, like not the TinyGo compiler, but regular Go compiler, to make a WebAssembly Hello World. And that it was like 10 megabytes or something because of the garbage collector, because they also included this into the binary, which is crazy. Of course, you don't need it. And then they actually recommended, like, don't use this because of this. You will get extreme large binaries. Use the TinyGo instead. But maybe they have improved. Maybe now, even if you use the classical Go, if you say my target is WebAssembly, it will not compile the garbage collector anymore. So I don't know. I haven't been doing anything with the WebAssembly for 6 years. Andre says, I know of a fun thing you can do with WASM and Zig. Let's see. I'm all ears. There is a WASM for Fantasy console, which runs games written in WASM. Would be fun to port tic-tac-toe. Oh yeah, that would be interesting. So WASM for Fantasy, it's called. Let's see if I can see it. Yeah, I will definitely look into this. Oh, cool. I will I will not watch it now. I will just put it here so that I can watch it later. Nice. Thanks for the info. It's very interesting. Otto, hello Otto, welcome. Thanks for the explanation. No problem. I enjoy these kind of things. Okay, let's go back here. So WASI. So from what I remember, the first target that they had for WebAssembly was browser. So this runtime in the browser, and then they worked on WASI. So I forgot what it stands. System interface. Yes, WASI here, which is kind of like a container that you can also use. Like you can run Node.js. You use Node.js to run JavaScript out of the browser. So the same idea. So just for WebAssembly, you can run it now anywhere you want as a container. But I haven't touched this at all. So I just played within the browser with WebAssembly. And I know they worked a lot on this. So they had some problems at the beginning. I forgot even what was the problem. But I believe they have improved it, and I had never used WASI. Let's see what they say. Zig support for WebAssembly system interface is under active development. So still. Example of using the standard library and reading command line arguments. Let's see what they do here. So they import the standard library, the main function, one variable, general purpose allocator. They take this one that you said that it's now different. I forgot the name, but I remember you saying that it's not the same name anymore. Then they take they set it to this .init. Then GPA constant, general purpose allocator, okay. Then args, try std process. This is flashbacks from a few days ago. GPA, then defer, standard process args free, GPA and args, okay. Then they have for loop. They go from the arg through the args, right? So they go from the 0, so the first one. They take the arg from the args and they just enumerate it, let's say. They provide a number that will match it. And then what they do is they just print. And what they print both the I, the index, and the argument. And then here they call this, so they say build exe, WASI args, okay, so this is the target, right? No, these are now the args, and this is the target I missed. So here, this is what they say that they are targeting the WebAssembly 32 architecture, 32 bits architecture. And then we can see what came from the command line as the args. So first WASI args WASM, okay, then 1, 2, 3, then hello. And where did this come from? 1, 2, 3, and hello. Here I'm blind. So this is just the compilation. Sorry, I thought that was calling them. Okay, so here they call. Here they just compile. Here they call, and then here now it makes sense. So WASM time. Then WASI args.wasm is the first argument. Then 1, 2, 3, right, is the next one. Then hello. Yeah, okay, it makes sense. And this WASM time, I guess it's a built-in. I don't know. So I'm not sure how this works. If you install Zig, do you also get this WASM runtime, or you have to install it separately? I'm not sure, but here they are using it. So this is called WASI args, right? So they say Zig build exe WASI args Zig. They just say the target is 32 bits WASI, and this is just like out of the box they use it. So it has to be that it's in the language. Okay. A more interesting example would be extracting the list of pre-opens from runtime. This is now supported in the standard library. So you have support in the library here directly. Okay, let me see what you guys wrote. The purpose allocator was renamed to debug. Yes, debug allocator. Yes, thank you for reminding. They'll remove the general purpose allocator in 0.15. It's separate. So this is the answer for the WASI runtime. Okay, thanks for. So WASI comes separate. Okay, but okay. And do you know maybe when 0.15 will come out, just to have a general idea? Okay, let's see what they do here. They take the file system, right? Then so this is like the first time I'm seeing it, or I forgot maybe for when I used built-ins, maybe they also did here the same thing. Then they create again the same thing, allocator GPA. Now they say arena instance D in it, so I remember this also from a few days ago. Then they say they defer this, and then const arena instance allocator. Okay, pre-opens equals, and they pre-opens came from, where did they say? stdfs WASI. Okay, so yeah, it says here fs WASI pre-opens alloc arena, so pre-opens equals, so this is just like the arbitrary name that they used, but this is important that they use fs.wasi.preopens alloc arena, and they are then this is already like arena instances. They use this allocator and they set it to arena here. Okay, and then they use this arena. Okay, then they have for preopens names, they do the same thing. They generate numbers here, so this will be I. These numbers, pre-open is whatever comes from here, from these names. Then they print both the I and the pre-open, and then let's see what they print. So first of all they build, and then they run WASM time. This is the first flag, -dir equals dot, and then the second parameter, the argument here, is WASI preopens WASM. And now we are not seeing these things because we are not getting the args, but we are actually having these pre-opens. So we can see that std in is pre-open name, one of the pre-open names, std out, std error, and a dot. Okay. Yeah, so this is the end of the WebAssembly part. This is very, very interesting. I mean, of course, I will need much more to explore than these things. And first of all, I don't fully understand still how this works. Yes, I did it a few days ago, but I have to practice. So like today, when I tried to do something with the multidimensional arrays and play with the array of structs, I struggled because I haven't practiced. So no way to memorizing anything if you don't practice. But now I will remember forever what I did today, hopefully forever, when I struggled to do specific things, and then when I finally did them, I will remember how it shouldn't be done, at least. Okay. Yeah, so that would be it for today. I believe it's more than enough because it's in total like 3 hours of streaming with the previous and inline coding, which I haven't finished. Yeah, by the way, about that, so let me go to here. I don't need the docs anymore. So about the second part and finishing the n inline, I might do something that I haven't done before tomorrow. So I might stream extremely early, European time early, because I will have to do many different things tomorrow. And I'm afraid if I don't stream tomorrow in the morning, that I will not be able to stream before maybe even Sunday, this additional one. So I will do the regular day for sure, but I'm kind of like in a rush now to finish some things. And that's why I might tomorrow very early in the European time, finish the n inline, and then in the evening, in like around this time, maybe a bit earlier, I will do the regular 27 already, day 27. So I think this is how I will do tomorrow, that I will very early finish the n inline and then do the day 27. But if you don't see that I do that very early, then probably I'm going to do it maybe on Sunday. I will not have time before, but I will do these regular days for sure. So day 27, 28, all in the regular time. Jorge is answering about the versions of Zig. Nobody knows. 0.14 was released a few months. It's a young release. Loris Crow is trying to get Andrew Kelly to do a roadmap announcement for 015. Yeah. As long as it's not like the George R. Martin writing the, not even the last one, but the one before the last one of Songs of Ice and Fire, Game of Thrones, it will be fine, because he's already like 14 years into writing the book that is not even the last one. And when he's asked, like, he doesn't want to speak about it, so he just says, yeah, I know you only want this book. So everyone who needs to know knows. Yeah, that's cool. That's cool. Yeah, so it's I would do the same. So if you cannot make a promise, like for sure it's going to get out like in the next, I don't know, next month or whatever, next year, then you shouldn't. Because if you do make a promise and then you don't deploy, then people are going to complain. It's better like this. Okay, let's see what Jorge wrote. Loris is a core maintainer and Andrew is the creator. Yeah, I remember Andrew. But Loris, I haven't heard about him yet, so now I have. And Andre says, Andrew will be taking. We'll be talking about async and Zig in a week. Do you know where? Is it like some conference, like in person, or is it a web stream or on YouTube or somewhere else? Do you have any info? This is interesting about the async and Zig, or maybe on X if it will be there. If you have any info, it would be great. Let me just drink a bit of the water. System distributed conference. Okay, I will look it up for sure and see. It's conference from Tiger Beetle. Okay, let's do this. And I will look at it later to see if it's possible to attend or if it will be a recording afterwards. Probably it will be at least that. It looks like Portugal, like these tiles that were the blue and white ones. Okay, June 19 to 20. Thanks for the update, for the info. Okay, guys, thanks for today, and see you tomorrow for sure once, maybe. I mean, I will be here for sure once, and maybe even 2 times. See you next time. Have a nice one. Bye-bye. And I have to click. Bye-bye.